Hello learners, welcome to Manifested Online Classes. Today we are going to look at a topic, the head of the topic is Loci. So before a learner should start the lesson, he should be conversant with geometrical constructions, linear inequalities, and properties of a circle, as this knowledge is useful as a foundation for the topic. So for geometrical construction, if you go to videos on the website, they were covered under Form 1. For linear inequalities, they were covered on the videos in Form 2. And properties of a circle, they were covered under the videos for Form 3. So that knowledge will be useful for us to go through the topic. The objectives of this topic are, at the end of the topic, the learner should be able to 1. Define locus, 2. Describe common types of loci, and 3. Under construction, you should be able to construct loci involving inequalities, loci involving chords, loci involving points under given conditions, and lastly, to construct intersecting loci. So under the introduction for the topic, we shall use an example. There is an example under Secondary Mathematics Students Book 4, as it is seen there. So I'll take my time to sketch a sketch on the board under the introduction, which will help us to move on. So if you look on the board, we have a very practical example of a door. We know when we open a door, we know how you open a door, it has to swing. So we have the door as it is shown there. So I'll show the hinges. There's a hinge there, P, hinge Q. So it's maybe a door entering a building. So you're told as you open or close it, it is swinging through an angle of 60 degrees. So when you close the door, the door would be moving. You can consider a point A on the door. Let's say it had been opened at 60 degrees. How will that point on the door move? So you can come to 1 and say, when opening the door, the point A on the door will swing through Yes, so to explain that, we have 1. When opening the door, point A on the door will swing through an arc EA. Therefore, point A will trace an arc EA. So we've looked at a point on the door. In point 2, so to explain the second point, a line on the door as it swings to close or open, a line on the door DA will sweep through a sector DAE. When I talk of a sector, it will create an area. So it will sweep through an area or a sector E, D, E, A. And 3, so looking at 3 again, the door itself, A, B, C, D, will sweep through a shape that will create a solid. That solid, if you look at it well, it is a fraction of a cylinder with a sectorial angle of 60 degrees. Having seen the 3, it will be able to give us a proper definition of a locus. Locus is singular, loci, plural. Like if there are 3 of them, those are loci. But if it is 1, it is a locus. So we shall then go to the definition of a locus, what a loci or locus is. Locus is therefore locus is the path so that gives us the definition of a locus. That's why I had to go through the first explanation, the second one, and the third one. So a locus is defined as the path, area, or volume traced by a point, line, or region as it moves according to some given law or laws. That is why in the first point we used, the first explanation we used a point. In the second one we used a line. And in the third one we used a region. A region defined by A, B, C, D. That is why it generated a volume. So that gives us the proper definition of a locus. So as earlier said, locus is one, loci are many, the plural. So having gone through the introduction, we are yet to look at some practical, we have some practical observation that can enable us to look at actually what a loci or locus is. So I'll just write around 2 of them on the board, and I'll be able to sketch the loci or the locus of that. So it is under exercise 3.1. It is exercise 3.1. Exercise 3.1 from the student's book 4, as seen. So we have the first question, which will enable us to sketch the locus of the point in question. So the question goes, sketch and state the locus of the tip of a minute hand of a clock during a 30-minute interval. During a 30-minute interval. So the conditions there are very clear, isn't it? So from the definition of a locus, there is a law or something that is guiding us to get that. There is that 30-minute interval. So to do that, we have to sketch the clock face. So if we have a clock, usually the minute hand is longer than the hour hand. So this is the minute hand. So if it has to go through the 30-meter interval, it has to sweep, because we know if you're at 12, when you get at 1, those are 5 minutes. So for the minute hand to sweep through up to 12 again, it is 60 minutes. So that interval there is 5 minutes. So we shall have 5, 10, 15, 20, 25, and lastly it will have swept up to that 6. So we have to go back to the question. It was not the hand, it was the tip. When you talk of the tip, isn't it? It was not the whole hand. Like in the definition, we talked of a point, then a line. So you'll find this will be the tip. You be very careful. It is the tip. A tip is like a point, isn't it? So during that 30-meter interval, if that was our originating point A of the tip, you can come and say here it is the final, A prime will be the final position of the tip after 30 minutes. So looking at that, you need to be very careful. It was a point, which is a tip, and not actually a line. A line would have given something else. So the trajectory made, this is an arc. It will make what we call an arc. This is an arc. So is it enough to say an arc? Isn't it? It traces an arc. There is something else you can add. This is 180 degrees, isn't it? Because you don't know whether it is quarter way or halfway. So the locus drawn so the locus of the tip will be an arc semicircular in shape covering 180 degrees. So having done that, we shall also look at the next question, number 2 of the same exercise. Number 2, where you are told you state and sketch the locus of the minute hand. So number 2 talks of you sketch and state the locus of the minute hand of a clock during a 30-minute interval. So because they have told us to sketch, we must draw the sketch of the clock face. So with the sketch, on the board, we had, they told us the minute hand of a clock during a 30-minute interval. So it starts here, 5 minutes, 10 minutes, 15 minutes, 20 minutes, 25 minutes, and finally 30 minutes. So, as I said, you should be able to identify whether it is a line, a tip, or a region. So in my case, they are talking of the hand. That's why I've drawn, this is the hand. That is a line from the center of the clock up to the tip. So it is actually a line sweeping through. So it will be not the same as the tip. So if you look at this region, it will be able to, you'll have that region or area and indicated as region. So it is a region. This is the region the hand will sweep through during the 30-minute interval. So the locus of the minute hand will be a sector or an area half of a circle. So having come to that point, before I give the assignment, we shall do a recap of what we've learned in this lesson. In the lesson, we defined what a locus is. And we said a locus is defined as a path, area, or volume. It is a path, area, or volume traced by a point, a line, a region, as it moves according to some given law or laws. So if you look at our example, we mainly tackled two of them, where we have a line, where we had a tip in the cloth, and a line which was associated to the minute hand. Isn't it? So like in the first example, we had a tip. Isn't it? It is a tip indicated by a point. So the point will give a path. In the second example, we have had a hand. You can see the hand sweeping through that area. So in the third case, we would have had a region sweeping. The region would have been A, B, C, D, the whole door sweeping. But in our subsequent lesson, we are going to tackle the third one, which involves a region that will generate a volume. So having come to that point, I'll give you an assignment, number 3 and number 4, which you'll have to work out during your own time. So let me write them on the board. So the questions are there. Just read through before we come to the end. Question 3, you'll sketch and draw the locus of the axle of a bicycle as the bicycle moves through a level road, and lastly, the bob of a swinging pendulum. So having come to that point, at least we shall at least be able to do the questions well, having gone through the definition. So have a nice time as you go through the work, and bye.